So on this episode of Mathmeatics, we're going to proving the quadratic formula, and I'm going to tell you why would I want to do this? Why would I want to prove the quadratic formula? Well, there's a couple of reasons why I want to prove the quadratic formula. I want to show how it will work with any quadratic and how completing the square leads us to the quadratic formula, and how everything that we've learned from one-step equations, two-step equations, inverse operations, fractions, multiplication, square roots, how it all leads up to this one beautiful point. So we have our standard equation, ax squared plus bx plus c, and that's equal to, we're going to start this off and say f of x. All right. Now, you might want to ask, well, how does this standard form leads us to the quadratic equation of x squared is equal to negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a? Well, ladies and gentlemen, I'm going to take you right to it. All right, so we're going to first set our standard equation into a form that will be more conducive to us completing the square. So I'm going to move my c over and also set my equation equal to 0. So this is going to become ax squared plus bx, and that's going to be equal to negative c. I'm skipping a step here. The step that I'm skipping would be ax squared plus bx plus c, and replacing f of x with 0, or replacing our y with 0. So we're skipping that step. That's okay, we can do that. Now I'm going to divide by my a term, and I need to divide the whole equation, both sides of my equation, by that a term. So then this becomes x squared plus bx over a, and that's equal to negative c over a. All right, so now we're going to complete the square. We have it in our form that we can complete the square. So that means that I'm going to take this b over a, and I'm going to divide this by 2. This is then going to become b over 2a. Little side comment here. If you notice, your axis of symmetry is x is equal to negative b over 2a. Question mark. Maybe that has some sort of relationship to it. I bet it does. Anyways, moving on. We're now going to take this term and square it. And that's going to give me b squared over 4a squared. And now I'm going to add this to both sides of my equation above. So this is then going to become x squared plus bx over a plus b squared over 4a squared. That's equal to negative c over a plus b squared over 4a squared. Now, I'm going to move things around here just a little bit because this is my rules of algebra. We can do this. I'm going to switch these two terms just because it's going to make it look a little bit more pretty for us. And then at the same time, I'm going to take my left perfect square trinomial and put it in a perfect square binomial. So this is going to become x plus the square root of b squared is b. The square root of 4a squared is going to give me 2a. And all of that is going to be squared. This is going to be equal to, now I'm going to switch these two terms. So this is going to become b squared over 4a squared minus c over a. Now there's a couple reasons why I want to do this. If I notice and look up top here, my b squared term is positive and this term here is negative. So that's going to kind of get it a little bit more into that format of that I'm looking for. But it's also nice for us to put it in this form so that we don't forget that that negative is there. All right, now I need to combine my fractions. In order to combine my fractions, I'm going to go old school math here, and I'm going to create a common denominator. So I'm going to multiply this c over a term by 4a. I don't need to do 4a squared because that's 4a squared, and this is a. I already have one a there. A times a is going to give me a squared. So now this is going to become b squared minus 4a times c is going to become 4ac. All over, this becomes 4a squared. Oh, look at that. This is already starting to look like our quadratic equation. Now, I'm now set to where I can take the square root of both sides. So I'm going to take the square root of both sides. So I'm going to take the square root of that side, square root of that side. This is now going to give me x plus b over 2a. That's going to be equal to plus or minus. This top fraction, remember, when I'm having a fraction, I need to square root the top and the bottom. So I can't take the square root of b squared minus 4ac. That has to stay. I won't simplify. Okay, so that's going to be 4ac square root of all over. Well, the square root of 4 is going to give me 2. Square root of a squared is going to give me a. All right, well, now this is starting to look kind of promising. I now need to isolate x. So in isolate x, I'm going to move that b over to a over. So inverse operations, so minus b over 2a. So then this is going to become x is equal to. Now, I'm going to go ahead and put that minus 2a, b over 2a first. This time, just because that's a plus or a minus. Okay, and also I'm going to show you why in just a minute too. There's another reason why. So that's going to be minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Now, if you notice also, this here is that number that's underneath our quadratic formula. Now, this is looking really promising. This looks a lot like our quadratic formula. This is negative b. This is plus or minus. This is the square root of b squared over 4ac. And we have 2a in our denominator, so let's just make this simplified. So this becomes x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, look at that. Woohoo! We did it. Yes, we have the quadratic formula. Quadratic formula. We proved it. And I'm spelling that wrong. I'm making this video look gorgeous and then I mess it all up at the end. Okay, let me make it look pretty. So formula. There we go. Now I can spell. We have proved